So now we're going to be using something called the Rachford-Rice Equation to perform a flash calculation. So a flash calculation is if we have some sort of system where we have a feed, and then it heads into a big drum, and we have a few different components, and we want to separate the components. And we want to remove the liquid and the vapor. And these liquid and vapor phases are going to have different concentrations of our feed. The components in our feed, for example, with benzene and toluene, the vapor might have more benzene or toluene, and the liquid vice versa, depending on our concentrations or our pressure and our temperature in our flash drum. And we're trying to derive an equation that allows us to determine the different concentrations of each of those components in our outflows. So let's start off by defining a new variable that we're going to be using throughout this, and it's going to be Zi. So we already have Xi and Vi. Or not Vi, Yi. There we go. And Xi and Y are just the liquid and the vapor mole fractions. Zi is going to be equal to the sum of those two, and it's just the total mole fraction of our. That's not necessarily correct. It's just going to be the total mole fraction of that substance within the total feed. And so if we define a few more things, F is going to be our total moles, and that is equal to the sum of the total moles of the vapor phase and the total moles of the liquid phase. And this is for our total feed. To find the specific moles of each component in the vapor and the liquid phase, and the total moles of that component in the feed, we can rewrite this as FCI equals VYI plus LXI. And again, we're basically saying the mole fraction of Zi within the total feed is going to be equal to the sum of the liquid and the vapor phases of that fraction or of that component. From here, we're going to define one more thing. We're going to say Ki is going to be equal to Yi over Xi. And all this is saying is it's the ratio of the vapor phase to the liquid phase. And then if we were to rewrite this again, it would be the total pressure divided by the saturation pressure. Again, this is just for a specific component, the ratio of the mole fraction of that component in the liquid phase, or in the vapor phase, compared to the fraction of it in the vapor phase. Sorry, let me try that one more time. The fraction of it in the vapor phase compared to the fraction of it in the liquid phase. So if we rewrite this one more time, we can say Yi is going to be equal to Ki Xi. So if we want to rewrite our equation over here, and from here, we want to solve for Xi. And actually, it's fairly simple. First, let's remove the Xi from this term over here. And then we can divide across. So from here, let's take a look at the term VKI plus L. We can actually rewrite this by substituting for L. We know that L is going to be equal to F minus V. So we can rewrite this as VKI plus F minus V. And then once again, we can rewrite this as F plus VKI minus V. And once again, F plus V Ki minus 1. So if we want to substitute that back into our equation over here, the total moles times the mole fraction is going to be equal to F plus VKI, or sorry, VKI times, or V times Ki minus 1 is going to be equal to Xi. And then from there we can do one more small little algebra, and we can divide across by F, and we'll end up with Zi over 1 plus V over F, and again we're just dividing by the total moles, times Ki minus 1 is going to be equal to Xi. And the reason we did that is because we have these two F's here, and we just wanted to simplify it a little bit. And the interesting thing here is that this V over F is going to be equal to the vapor fraction. So to actually derive the Rachford-Rice equation, we're going to start off with a similarly simple assumption or equation as we did before. And we're going to say the sum of each of the vapor components minus each of the liquid components is going to be equal to 0. And this makes sense because with some components or some substances, some of them will have a higher vapor fraction, some will have a lower vapor fraction than liquid, and overall they have to equal 0 for the system to be possible. So we can go ahead and substitute for Yi, and once again we have Yi equals Ki Xi. Equals 0. And you might be able to see where we're going with this. But once again, we can pull out the Xi, and we're left with Ki minus 1 equals 0. And then we have an equation for Xi over there. So all we have to do is substitute that in. And we'll end up with Ki minus 1. And I'm just writing the equal 0 now to get it out of the way, I guess. Over 1 plus V over F, or the vapor fraction, times Ki minus 1 is going to be equal to 0. And actually a more accurate way to write this would be from I equals 1 to n. So by solving the system of equations that this will produce, we can solve for any of the fractions in terms of vapor phase or liquid phase for any of the components in the mixture.